Hey everyone. So today it looks like Hello Interview dropped this new feature for guided practice for system design. So I'm a big fan of the Hello Interview platform, the Hello Interview YouTube channel. I think they're really great people making those videos and building this content, and they're also very knowledgeable. So yeah, they pretty much dropped this guided practice for system design. And I haven't even really done system design in a long time since I got a new job. Probably been over 7 or 8 months. But let's see how this goes. So I'm gonna try to design the Ticketmaster and see how the guided practice works for system design. Hopefully I don't fail it miserably. But let's practice design Ticketmaster. Practice is common problem step by step. Receive instant feedback as you progress. Okay, cool. Start practicing. So design a ticket booking service similar to Ticketmaster. So Ticketmaster is an online platform that allows users to purchase tickets for concerts, sporting events, theater, and other live entertainment. Okay. The functional requirements are users should be able to view the events, so see all the events that are active. Users should be able to search for events. Users should be able to book tickets to events. And the scale of the system is 100 million daily users and 100K events per day. Wow, that's a pretty crazy scale. So we'll walk you through our recommended delivery framework step by step. We recommend you follow this framework in your real system design interviews. So we do requirements gathering. We do core entities. The primary goal is to satisfy requirements. API design, data flow, high level design, then deep dives. Yeah, I agree with that approach. So the first question, what are the non-functional requirements of the system? Write your answer on the whiteboard, then click get feedback button. Already a bit weird because I feel like most in most system design interviews, you're going to be given the question design Ticketmaster, and your job is to figure out the functional requirements for that interview. So you start asking questions of pretty much figuring out the scope of the problem. They don't usually just hand it to you like that. So I think they should have some feedback for this would be we should have asked us to figure out the non-functional or figure out the functional requirements by asking questions to maybe the AI or whatever here, or writing down what I think the functional requirements should be, and then like iterating on that because that simulates a lot of the interview. And I feel like the non-functional requirements, you get a bit more help on that versus or like figuring out because some interviewers might not care about some functional requirements. So yeah, I feel like the non-functional part we that could be improved there. That's first thought off the mind. First question is what are the non-functional requirements? Cool. Okay, nice to have Excalibur. Classic. So Ticketmaster is an online platform that allows users to purchase tickets for concerts, sporting goods, theater, and live entertainment. So we have the functional requirements. Users should be able to view events. Yeah. So let's see. Are statements about the system qualities that are important to users. They can be phrased as system should be able to or system should be. You'll use these to lead your deep dives later in the interview. You should aim to spend about 5 minutes on this step in your real interview. Okay. What else do they talk about here? Functional requirements and then system scale. Okay, they already told us the functional requirements and the system scale. So qualities. Let me answer first, and then I'll read the left side here. So users should be able to view events. I think when we're thinking of the cap theorem here, right? I think consistency is more important for this problem because we don't want the same person to double book or basically we don't want any double bookings or we don't want to mess up any of the bookings. So I think consistency is important over availability. Like if the site just goes down, that's fine because people will want that ticket. I'm let's see. Yeah, we'll think about that. Well, let's say, because also one thing I just remembered is what there's parts in the system where we can go for consistency, or other parts that we can go for availability. It's not like the whole system has to either follow consistency or availability. You know what I mean? So let's just say, so when I'm thinking about this, I think probably when it comes to booking tickets. So let's see, non-functional requirements, consistency when it comes to actually buying tickets. But if we want to just view the events, it should be highly available, right? We don't want the site. We can make it so that the site is highly available, but when it comes to buying tickets specifically, we prioritize consistency over availability. So, so for view events, prioritize, and I'll just write down the notes there. Prioritize availability when it comes to viewing events and searching events, right? And then prioritize consistency when comes to actually buying tickets. So it's not like, yeah, we can have that trade-off depending on each system. I think with just viewing events, let's just make it highly available, but then when they go to the checkout flow, we'll make that very consistent. And yeah, users should be able to search for events. Users should be able to book tickets. What else? We definitely, of course, we want things like let me think. Availability, low latency. I think low latency is always nice, especially when it comes to viewing the events and things like that. Users like a fast experience, so let's just say low latency when it comes to viewing events. And yeah, what else? Low latency when it comes to searching events as well. And searching events. Yeah. And then with the like I said again, with the buying the tickets, we just need to make sure that event, that booking flow is as pretty much fault tolerant and resilient as possible. So a lot of times when you like you'll need to sacrifice a little bit of availability for that. Yeah, let's see. So let's look at the left now. Consider the cap theorem, environment constraints, scalability. Yeah, it definitely needs to be scalable. I'm not sure if I think with every system, especially when the scale is that high, we need to make it scalable. Durability, yeah, definitely related to durability, security, fault tolerance, compliance, etc. Definitely, we want it to be resilient. We don't want it to just crash and then people lose the tickets they bought. So definitely durability when it comes to. I'm trying to be, because you could just be very specific on the whole system. Oh, we need it available, we need it scalable. But I think I'm trying to go a bit deeper, because you can prioritize different requirements for different parts in your system. So durability when it comes to specifically people's tickets that users ordered. Cool. Put in the context of system, for example, low latency is far less meaningful than low latency. Whenever possible, try to quantify your. Okay, that's kind of what I was saying here. Put your non in the context of the system. So instead of just saying we want low latency, we need to say what low latency when it comes to this, or when it comes to searching events. Whenever possible. Try to quantify your non-function. For example, latency could be. Okay, I didn't do that. Choose your top 3 to 5 non-functional requirements that are most relevant. Every system should be scalable, for example, but is there something about the system that makes scalability challenging? I don't know. Okay, let's go with this response, and then let's get a grade. How do we get the feedback? We pretty much say we want to prioritize availability when it comes to viewing events and searching events. We want to prioritize consistency when it comes to actually buying tickets. We want low latency when it comes to viewing events and searching events. And then we want durability when it comes to tickets the order is used. I think those are like the 4 main things that we need to capture. So prioritize no double booking. Okay, let's get some feedback. Reviewing the whiteboard. Okay, it went decently well. Oh, I didn't talk about scale. Oh, okay. Wow, this is good. So you consider the importance of strong consistency for ticket booking and ensuring no double bookings occur. That went well. You recognize that the need for low latency in search operations, which is essential for a good experience. What I didn't do was scaling. Or let me move myself a little bit because I'm blocking. So what I didn't do is scaling to handle bursty. That makes a lot of sense because if there's a Taylor Swift concert, it's going to burst. Okay. I didn't think about that. So how can... It's essential to design the system. Okay. Definitely the bursty part I should have wrote down for sure. And then consider quantifying the low latency requirements for search. And so, for example, you might specify should be returned. Okay. Let me try it again. How do we get the feedback again? Do I need to buy? Okay. Yeah, definitely I need to write this. I need to definitely do that. Definitely handling bursty traffic is very, very important. With a lot of systems, you want to handle bursty traffic. I should have thought about that. Handle. And then quantify low latency when it comes to search. Probably 200 milliseconds is really fast for the naked eye. So try again. Oh, I should have like handled bursty traffic and explained it. Okay, nice. Now with just those two extra things that I added, 200 milliseconds here and handle bursty traffic, it really said you successfully have all the important non-functional requirements for the system, including strong consistency for ticket, low latency for search, and the ability to handle bursty traffic. Your contextualization of each requirement was well done, showing us clear understanding of why each is important for the system. Okay, let's view the sample answer. So this is what they say. Consistency for booking events, no double booking. Availability for searching and viewing events. Scalability to handle popular events. And then low latency search. Okay, looks like... nice. Was pretty close there, but let's keep moving on. This is I'm already liking this platform, but I wish they did that for the functional requirements. So you could learn how to talk to an interviewer and figure out what the functional requirements should be. Oh, wow. Okay, this is a real system design interview. I'm gonna get some water. Give me a sec. Let me pause it. Back. Okay, what are the core entities of the system? Write in the green box on the whiteboard, then click for the feedback below. So we have to start writing the core entities. So we're designing a Ticketmaster service, right? So users should be able to view events. Users should be able to search for events. And then users should be able to book tickets for an event. So what I'm starting to think is, I'll probably take a screenshot of this so I can scroll down. Scroll down here. The editor is a bit weird on this. That's another piece of feedback. But let's go into the core entities. So I'm thinking definitely we'll have tables for users. We'll have like a user ID, which is a primary key, and gonna be like a UUID. So we'll have users. These are people who sign up to their platform. They might have a login and stuff like that. Then we'll have users should be able to search for events. So we'll have events, and we probably don't need to worry about categories and stuff like that, because there would be some places that have categories like rock concerts, etc. But let's just go with events. Everything pretty much needs to have some sort of ID, event ID, and then let's make a tickets, and let's see if this is naive, and then we'll figure out the rest of there. There's a lot of different table stake columns when it comes to the data, like created at, which is timestamp, created at, updated at. This is good for just logging. It's nice to have all those. So created at, updated at, created at, update at, tickets. I'm already really liking this platform. This is, I would pay for this. This is great. Hello interview, good job on all the videos. Good job on all the platforms. This is really great stuff for people to just, even if you are working your normal job and you want to learn system design, this is honestly great. I see a lot of potential in this. So we have our user's ID. We have our ticket ID. Ticket ID should have a, so we'll just go with SQL database for now because we want to prioritize consistency. So we set consistency when it comes to buying the tickets. So with the SQL database, we can do things like transactions to just make sure that only one person is able to grab that ticket. And you could do the same thing probably with a NoSQL database, but I'm just thinking the SQL database would be a lot easier because it's more ACID compliant, right? Or yeah, ACID compliant. Saying some buzzwords. Okay, tickets. We say event ID. There's a foreign key. We'll have a foreign key to, and one thing that's good about having a SQL database here is we can easily cascade deletes as well. So if we delete an event, we can just wipe out all the tickets easy, instead of handling that in application logic. So event ID is also a UUID, foreign key to event ID in events. And then what else? This is also UUID. And what else? So basically as a user, I sign up, I can query the different events. I can query all the different events. Events have name, probably, date, maybe category, like I said. That's probably not important. Category. But I think definitely when you have an event, you need to know the event. You need to know the name of the event, the date, the category, and a bunch of the metadata. Let's just say we're going to store that in a JSON for now to be lazy. Maybe I'll get docked on that, we'll see. But all the different data about that specific event should be there. And then after, we should generate tickets for that event ID. Different things like arena or whatever, or venue. I think that's all important stuff. But we can go on for days of things that we want to store in events. I think the main thing is just having an event, and then the relationship is there's events and then there's tickets that belong to that event, and each ticket could like have different seat numbers or something. You could generate one ticket per seat. That's usually what happens. I don't know if we want to store that in our, because some places might not even have seats. So let's just say, I think the important part is you generate tickets, and yeah, maybe seat ID if applicable. Right? Because different venues have different ways of seating. It could just be general admission, stuff like that. But let's see. Yeah, we have our users. We have their email. Probably a password. Definitely not a string. This should be some hash. This should be hashed for sure. But yeah, we pretty much have our users. our events, then we have our tickets, and I think that will handle it. Just taking a step back to think about it. I'd be viewing an event, or I'd log in using my credentials, and then now I'm authenticated, and then to grab the website, I'll pretty much just be looking at all the different events, and the events are populated based on the events ID. And once I click into them, we'll know what tickets are available and stuff like that based on the database for the tickets. And yeah, that's kind of what I have there. So let's look to the left and see what they're saying. And wow, I spent way more time than they said to do it, but it's kind of no need to worry about this full schema. Oh, I just listed out the full schema. Choose clear. Okay, whatever. Get feedback. Woo! You correctly identified all the core entities, users, events, and tickets. Use reasonable synonyms for the entities. Whatever, let's move. Okay, getting into the REST endpoints. I like this. I really like this platform. What are the external REST APIs that your system will expose in order to satisfy the functional requirements? Write your answer in the green box on the whiteboard, then click below for feedback. So, okay, we're gonna just define our API routes. So definitely like a login route. Probably don't need to worry about that right away. But let's say we have to take a step back and think about it from the user's perspective. So when I first do it, I'll hit a login, and then usually a login will return me some sort of cookie that will, once I have the cookie, I pretty much send that cookie in, and that cookie will allow me to get access to my session ID. And the session ID will be figured out by the backend and just verify that I'm authenticated. So maybe login returns like a cookie to store on cookie, JWT, whatever way you want to log in, or JWT, etc. The client keeps, right? So we can either log in. Once we're logged in, what can we do? We can view all of the events. So we'll probably want a get. So post, you'll usually want to post in your creds. So post, and pretty much the body of this is probably equal to what would be the body? Definitely your username and password kind of thing. Obviously encrypt it. Probably want to hash it. Oh shoot. What the? Say returns cookie. So whatever, we'll also want to get events. So that will get all of the different events. And what I just noticed we're not talking about, and what we don't need to worry about, is how events get populated, because it's just talking about users should be able to view, users should be able to search, and then users should be able to book. It's not talking about, oh, as somebody who's trying to host the concert, I need to use the platform and insert events. So we don't need to worry about that. So we don't really need to make API endpoints for that. We just say, okay, we want to get events, and that returns pretty much a list of events. And probably we can have different query params to search for searching. I don't know, like maybe query parameters category, helps filter category. Yeah, this could be a get endpoint, or it could be a post endpoint. I would say if you have a lot of query parameters, it's better to just make it a post request, because and then put that in the body. But I mean, I think get makes more sense here. So get category, what else? Get name if you want to search for a name. So we have to get events, and then this returns back this will return back a list of events. We'll say cookie. Yeah, cookie or JWT. So, etc. So we have the query parameters to be able to grab all of the different things from here. Like that will help filter it. But then that will get a list of events. And then if we want to get a detailed look at an event, that's also a different endpoint. So pretend they have a list of events and then they click on a specific event. What we can do is we can essentially, oops, probably shrink this. So we get events here. We can actually get a specific event. So get events, pass back event ID, or you pass in a specific event ID, and then you get back one specific event. And this won't have query params, but it has a path ID, which is, or event ID. ID is the path param to the unique. Event ID is the path param, and we pass in. And we pass in the UUID for the event. Cool. That's kind of, now when we get the event, we can also within that also just grab all the tickets for it. But let's just say let's just do be able to grab tickets. So tickets. So get tickets for a specific event ID, and it'll give you a list of tickets. And then finally, let's move a bit faster. So we should probably describe what each does. So we say this is needed for post description, needed for logging in, although that's not a direct requirement. It doesn't really talk about authentication. I'll just bring it up anyways. Probably like wasted time doing that actually. So I don't know. Let's see if it docks me. Description. Needed for getting all events to list on the website. Pretty much the main view. Description here. Needed for when a user clicks into a specific event on the website. And then description needed for what needed to grab tickets that are available for a specific event. Yeah. And probably if you want to view your own tickets, that's probably a different one. But that's not even a functional requirement. So let me see how it does without that. So rest. Yeah, we're not worrying about like updating and deleting. Oh wait, no, we need posts for getting tickets. So you should be able to, so we should be able to get a specific ticket. Sorry, I'm already writing way too much stuff here. Login, like, I don't know why I did that. I wasted too much. I shouldn't have mentioned that. Although, probably, it's still good to know that. So, you get tickets. And then, let's say there's another function for literally post for tickets. You want to be able to post ticket ID. And then you'll probably get back the ticket, but what you're gonna do is use for buying a ticket. So you can do a post request to buy a ticket, then you can get tickets. Yeah, you can basically, let's think about it. We can view the events. We can click into a specific event. Once we're in the events, we can see the tickets. Okay, we don't need that. Once we can see all the different tickets, and then we can choose one and kind of check out and buy it. So okay, let's see. Let's just get some feedback. Let's go. Great answer. We're acing this so far. But there's small suggestions. Sorry, I got too hyper too fast. What are the external REST APIs that your system will expose in order to satisfy? Write your answer in the green box. You provide a comprehensive set of API endpoints covering all of core functional requirements for the ticketing system. Your API design includes endpoints for viewing events, searching for events, and booking tickets. Yeah, viewing events, searching, and search could be a whole different endpoint too. And booking tickets. You included query parameters for filtering and get events. Okay. Oh, okay. Some small suggestions. Consider adding pagination to get events. Yeah, you're right. The post could be the post tickets could. So the post tickets / ticket ID endpoint could be renamed to post tickets for consistency. Oh yeah, that shouldn't probably not be in the path there. It should be part of the body. Yeah, like I mentioned, the post, it doesn't really cover the core requirements, so it looks like it complained about that I did that. Wow, this is a good platform. Yeah, I shouldn't be doing that. I shouldn't be like getting into authentication when that's clearly not a functional requirement that we need to care about. So I probably spent way too much talking about that. Talking about that when I didn't need to. So let's just say for ticket ID, we'll pass in the ticket ID to the body. So we'll just be like body. Ticket ID. And then, yeah, definitely for the events you would want pagination. So let's just say query params, probably like limit and offset for pagination. That's more naive way. We get like there's better ways to do pagination than that, but that's try again. Nice. Oh my god. More suggestions? Quest. I see. Okay, whatever. It's already said they loved it. I could probably keep optimizing it that all day for what the AI wants, but let's see what the view. Wow, theirs is way quicker. So view events. So what are they doing? They're getting events. They're passing in a specific event ID, and then they're adding ability to search for events, and a bunch of query parameters, and they get back a list of events. So what they're saying is when you click the event, you get a venue, performer, and the tickets. And then you could have a different post for bookings. Yeah, I probably added way too much more than I needed there. But, yeah, I don't know. High level design. You'll start first with the functional requirement and build your way step by step. Cool. Then explain how your design satisfies the given requirement, either via voice or text. Don't worry about being perfect. Just talk to your design. So start with your high-level design by answering the question, how will users be able to view events? So I'll just keep that here. So dude, this is a great platform. Okay, it's already there. Huh? Wow, this is a great way to study system design. I'm not gonna lie, this makes it way funner. So how will users be able to view events? So pretty much we'll have the different clients over here. Let me write it down. So we'll have the different clients. Dude, how do I just draw? Okay. Since we'll have the different clients and then they'll just be circles. Maybe we'll just draw. Okay. So there's the different clients. Actually, let me use triangles for the clients because I like circles for the database. So I have clients. Clients, there'll be like one to many, right? And then typically I would do ... Let me fix this. We have the different clients, and since we want it to be highly available, what we're going to do is, we'll have our database that stores all the different events. We'll just say it's a single database for now, just to keep things simple. And then pretty much what we're going to do is like put a load balancer there. And then all of them pretty much talk to the load balancer. And what the load balancer does is it will create different, or we'll have our different application servers. And that will just horizontally distribute the traffic. So we have the different app servers. What else? So now pretty much whenever someone wants to talk to us, they're going to hit this load balancer first. That will allow us, that means they just keep track of pretty much one IP address. And after that, it'll route to each server, kind of depending on round robin or minimum usage, whatever way that we decide to do load balancing. And the different app servers are going to handle all of the different requests. Figuring out, they're going to be pretty much stateless app servers. We'll probably have a different database to store the user sessions. I shouldn't keep talking about this user session stuff because it's a waste of time. But then we'll have the database for all the different events. We might shard the database depending on specific events, but we're probably going to want to keep all of the tickets and events of one specific event in one database. So we have a database that they can talk to, and pretty much, we can do something like this. And then we can start listing out the different, I can mention it. I'll just explain how it answers the question. So let's see. We'll have the different load balancers, and then we'll have the app servers. And then what we can do is we can probably store, we can also have like a Redis cache for all the different events that when they ask for events, we don't want to just keep running a bunch of queries. We could have a Redis cache or just any cache for common event details. Do something like that. So we can create a cache for the common event details. And first it'll check the cache. And if it's not in the cache, it'll actually create a database. So that saves some load on that. It makes it a bit more fast. And it's going to be highly available because there's going to be multiple servers. The database is not redundant, but we can do we can have copies. We can have replicas of the database, and then we can query from the database. Database has replicas. And then, yeah. Okay. So for your high-level system design, build your system step by step, addressing each API and functional requirement. Begin with the design that fulfills the first. You should be able to view events, then explain why design meets that by detailing how the request flow works in your system. Draw the system. This system consists of drawing boxes and arrows to represent different components of the system. How components are basically building blocks like servers, database, caches. The high-level design should be minimum design necessary to satisfy requirements. We'll add complexity later. If you add a database, cache, or other data store, list out the fields or columns for each entity stored in that data store. This will help the. So let's just say client makes request to load balancer. Load balancer distributes traffic. App server handles parsing request, calling into checking cache, checking DB, and then finally returning the response. That's the job of the app server. It's kind of like your regular API server. Then we'll say database contains tables for events, tickets. Yep. We can shard based on popular events. Yeah. Otherwise, if there's popular events or something, one database is going to be getting hit. So cache helps speed up queries for common event details. Probably store a key to event ID where the value is the event details. Something like that. Cool. Where's the feedback? Oh, now I have to talk. Oh, I just mentioned it all right now. Okay. Okay, let me talk to this guy. Draw some. Microphone and views. Okay, so we have clients, right? These clients make requests to our load balancer. Our load balancer will distribute the traffic to our different application servers. The application servers, or the way the load balancer does it is it could be naive round robin, or it could distribute it based on load or usage that's happening on each server. We can figure out the best algorithm for that, but there's multiple algorithms to choose from. Pretty much when what the app server does is it parses a request from the client, and then it does the necessary action to serve that request by either checking the cache, checking the database, and then pretty much building a proper response to return back to the client. So if the request was to grab certain events and they passed in query parameters, what this thing will do is it'll take the request, it'll parse out all the query parameters and generate the correct query so that we can search our database to filter out for the right data, essentially. And if it's doing any pagination or anything like that, it'll figure out where it will create the query in order to handle that. And then we also have a cache here, which it will be probably a write through cache, or there's many different strategies, but essentially at a high level, we can get into this later, but at a high level, we just want this cache because if we have multiple people requesting the same event details will hardly change, and we just want to serve that up quickly without putting that much load on our database. Additionally, the database will probably have replicas. So the database is we just want for events as we mentioned, we want high availability. So we'll have replicas of we'll have like a primary and secondary, and if the primary is down, it will read from the secondary. Cool. This is crazy. Great answer. Okay, I'm doing good at this one. Interesting. Cool. You provide a comprehensive high level answer that addresses the requirements of how users can view events. You design includes key components such as clients, load balancers, application servers, caches, and database systems, showing a good. You explain the flow of requests through the system clearly, including how the app server processes requests, checks the cache, and creates a database when necessary. Wow, this is way simpler. You literally just hit the client. You hit the API gateway. That makes sense. And then you hit the event service, and then you hit the database, and then it has the different things. From the client, the user initiates a get API call with the specific event ID of the event they wish to view. This request is rerouted through the API gateway to the event service. The event service queries the primary database for event details. The query also retrieves the relevant venue. The server then returns the data to the client, allowing the application to render all the necessary information so the user can make an informed decision. Cool. They did that way more concisely, but it still liked my answer, so. Next question. Holy crap, this thing is putting me to the limit. I don't want this video to be like 2 hours long. Might have to rush this at some point. Users will be able to search for events, draw a simple diagram on the whiteboard, and explain how it answers the question. So what we can do is, instead of searching directly here for the replica, what we can do is we can use something like, I'm gonna speed this up a little bit because this video is already 45 minutes. But that just shows how bad, like, I need to work on my time management, especially when it comes to the interview, and be a bit more concise. It's not giving me that negative feedback right now, but that's what I would take for myself if I was running up against that. And I just literally just rambled again. But essentially what we can do is we can build a system like Elasticsearch. So, or we can have a system called Elasticsearch. Right? So pretty much when it does the queries, what it's going to do is when people write into the database, as we write to the database, it updates the Elasticsearch index, and Elasticsearch, and then we just pretty much query the Elasticsearch index instead of the table for events. For searching. But then tickets and stuff, we'll probably just hit the regular database. So yeah. So how will users be able to search for events? So we'll have Elasticsearch for looking for events. Okay, let me explain it to the AI quick. So how will users be able to search for events? What users will do is they'll pretty much make requests to the load balancer. Then after they make requests to the load balancer, that gets routed to an application server. The application server will take the GET request essentially and parse out the different query parameters, which would be all of the different things that they're querying for, like maybe venue, maybe category, maybe specific artist. And once it does that, once it's able to parse out the category, what it could do is we could have a system like Elasticsearch where it's pretty much a key where we can easily search for those specific keywords and get back results. And when we get back, essentially what we can store in Elasticsearch is a mapping between some of the different keywords and then the IDs for events that have those keywords. And Elasticsearch will basically allow us to quickly find all of those instead of writing a query on our database. And once we have all of those IDs, then we just query the database using the event IDs returned to us from Elasticsearch. That's one approach. An alternative approach is just based on the query parameters. We can query the events database, and we can query the events database and pretty much select where events and then all of the different things we're querying for, and then just make sure we index the database properly so those are fast. But I think Elasticsearch might be a better approach here, especially we want to serve 100 million daily active users. And how the Elasticsearch indexes get updated is they get updated asynchronously as database data change regarding events, and we just update the Elasticsearch asynchronously using that. That's sort of what I'm thinking. See what it says. Oh, good feedback. That's one approach. Or we could just literally just query it, but I don't know about that. Nice. Okay, this is going well so far. You provide a comprehensive explanation of two approaches for events search using Elasticsearch and directly querying database. Your design includes a load balancer application serves a database with replicas, which demonstrates a good understanding of a scalable system. You considered performance implications of searching and proposed using Elasticsearch for faster queries, especially for a system serving 100 million daily active users. Cool. What did they use? What to search queries the primary database? Oh, they just query the primary database. Yeah, I mean, there's multiple ways to do that. I mentioned that as well, but I decided to just do a Elastic. It adds a bit more complications, but I think that'd be better. How will users be able to book? Am I in the deep dives? Yes, how will users be able to book specific seats for events? Each has exactly one ticket. Do not consider general admission or... Okay. Where do I write that? How will users be able to book specific seats for events? Each physical seat has exactly one ticket. Do not consider admission or general. Yeah. Here, let me think about that for a second before answering. So, how will users be able to book seats for events? I'm thinking every ticket has their own row in the ticket ID. Essentially, they can fight for those tickets by through the checkout flow. We're designing. Yeah. I mean, I already got. I'm kind of bored of writing out this high-level design, but where did I write it? So users will be able to book specific seats for events. Each physical seat has exactly one ticket. Yeah, what I'm thinking pretty much is that when events are created, based on the venue, we generate a ticket, which is going to be stored in our tickets database for every single ticket that person will need to have. Or sorry, we'll need to generate tickets for every single for we'll pretend we have a venue with 200 seats and we know all the different seats. We'll generate a ticket, or we'll generate 200 tickets that we'll insert into our ticket database, and those different tickets will be part of our tickets database. And I think how we modeled it before is that all of our tickets also have a seat number. So yeah, basically we'll just have a database for all these different tickets, and essentially when people try to buy it, first in the checkout experience, they'll probably select a specific ticket, and then they'll probably have 10 to 15 minutes, like a checkout flow, in order to choose if they want to buy that ticket or not, essentially. um, but the con is like we have to put a lock on that ticket, essentially, so no other people can get it, and somebody can hold it up. But eventually, after 15 minutes, that ticket, if the person will either finish the checkout flow for that ticket, or we release it again. But essentially, each ticket is an object in our database, or is a row in our database, and we can put a lock on it, and when somebody's in the checkout flow for it, and then release it when they're not in the checkout flow for it, and yeah, basically allow them to check out. So that's kind of how we'll be able to book tickets for events. We'll just have a bunch of tickets in the tickets database, one for each seat ID, and then users will try to fight for those tickets. I didn't write anything on the board. So let's see how it responds. Ah, okay. I have to update. Okay, because I'm getting lazy. Update the whiteboard to include the data schema with the tables and fields necessary to satisfy this part of the system. You can add them directly or next to the database. Okay, this video has already been an hour, so let me take a quick break, and I'll be back in probably like 5 minutes. You'll see it up there on the top left. Okay, we're back. So, what are they asking us? How will users be able to book specific seats for events? Each table has exactly one ticket. I mean, that's what the tickets database is for, right? So we have a tickets database, tickets, DB, or table contains a ticket for each seat. Tickets table contains a ticket for each seat. We generate these when the event is created, and the number of them plus seat ID is different per venue. Second, need to sneeze. Need to sneeze. So we have a simple tickets, right? And then I guess we can have our checkout service. So we have our different app service. This kind of serves our there, and then we'll probably have a checkout service. So they hit this checkout service and are able to check out, essentially. That handles sort of the checkout flow, which we said it needs to be very consistent. And we'll also have a payment processor, like Stripe. We don't want to handle that ourselves. But probably what we'll do is redirect somebody to the payment flow, and that will be handled through our payment processor. So, yeah. A little bit iffy on this response. Let's see if it gives me a worse mark. Tickets. Wait. For this, we probably just want to read straight off the primary. Probably a weak response. See if it works. Oh, I got it. Offer letter incoming. You provide a comprehensive of how tickets are generated for each seat when an event is created and stored in a tickets database. You describe a clear process for handling ticket booking responses. including implementing a temporary lock during checkout to prevent double booking. Your design includes a time limit for the checkout process, after which the ticket is released if not purchased, which is a good approach to event. Consider aligning your verbal explanation with your whiteboard diagram by including a checkout service and payment processor in a visual. Okay, I did that though. You may want to elaborate on how the system handles concurrent requests for the same ticket to ensure robustness in high traffic situations. Yeah, we could build a separate. We can build. There's so many ways to do that, but it looks like they just want, like, for example, we can use a Redis database to have locks, and then people, what we can have is all the different app servers kind of try to grab the lock from the Redis cache. And yeah, if it's able to grab the lock from the Redis cache, then it could go and actually access that ticket. And then afterwards, at some point, if they don't finish, then it gets put back in the Redis cache, something like that. Deep dives. Okay, this is gonna get crazy. There are 5 deep dives. Wow, this is crazy. Okay, start the deep dives by answering. Implement a two-phase booking process. A seat where temporarily holds selected seats. Booking. How would you design this to prevent users from losing seats? Wow, this is gonna get crazy. This is long, but very, very good. You select a ticket on the seat map. That should. You should aim to spend about. Update the drawing. I'm getting tired of drawing, not gonna lie. This is a lot of work. Okay. Implement a two-phase booking process, seat reservation. So I'm just gonna try to get through it fast and just talk to it, and let's see if it. I need to fix up this design. I need to make it smaller. Start deleting some stuff. Like, we already know how it's gonna scale and stuff like that. And then different app servers. Deal with the app server here. Elasticsearch for searching. This is our database, right? We have our different app servers that it's hitting. Then we have our different checkout service. We have our payment processor. What we can do is we could say we have a Redis cache for our locks. Right? So what we can do is it's a hard one, because what we can do is different app servers try to hit the Redis cache. We have a Redis cache for our locks, but how do locks get back in there? I have to think about that for a bit. But essentially, the app server will like fight for a cache for a lock for a specific ticket ID, right? Once it's fighting, basically now after that, we probably have like a time to live. What we can do is we can insert into the database the Redis cache. We can essentially have an entry for if somebody has a lock with a time to live, and then essentially after the time to live, it after it expires, it frees it up again, and someone else can get the lock. But if somebody actually pays for it, then we don't want that lock to go back in there. Okay, so what we can do is we could add like a message queue for that. Essentially, for the message queue, what will happen is after we grab a lock, we'll put an element on the message queue, and pretty much we'll have different consumers. Consumer, right? So what the consumers are doing, it's gonna look for locks. Basically, when you grab a lock, people will fight for a lock, and they'll be able to grab a lock. And then after they grab a lock, after they're able to grab a lock, what we're gonna do is put the lock on a message queue and put the timeout for 15 minutes. And pretty much the consumer is after 15 minutes, it's gonna check if that person has already finished checking out. If it hasn't, what it's going to do is um, sort of invalidate that lock and add that lock back into the Redis cache. So if they haven't paid for it, they lose the lock, and then we add it back into the Redis cache for someone else to grab that ticket. And if they keep pretend they go to pay for it, then we just need to basically say that that lock is invalidated at some point. We can have other checks for that, but that's one way to get it back into the cache for locks. So, but if they do finish it, we'll write that into database that they did finish it, and then when the consumer goes to take it out, when this consumer goes to take it out, um, when the consumer looks for expired or locks that have been in used up for more than 15 minutes, it will first query the database to see that if it should use it or if somebody has finished the flow. If they haven't, they add it back. If they do, if they someone did finish it, you just leave it. How would you design your this to prevent users from losing seats during the checkout? I mean, yeah, we have the lock. Okay, let me get some feedback on this. This is crazy. One, this is more of a marathon. This is just okay. Let me explain that. So number one, seat reservation. Temporarily hold selected seats, right? So how we're gonna be able to hold selected seats is that we're gonna have a lock for every single ticket, and essentially the first person to grab one of the locks has access to the checkout flow for that specific ticket, right? So they have to fight for the lock, and one person will get the lock for that specific ticket. And once they have the lock, essentially what we're gonna do is put that lock or put in a message queue that somebody pretty much put in a message queue that somebody took this lock, essentially. And basically in the message queue, we're gonna store when somebody grabbed that lock, and we'll have different consumers on that message queue. And essentially, the consumers will be polling the message queue to figure out if somebody has held the lock for too long. Probably at some point when like the 15 minutes is done, it's gonna look for, or basically it's gonna keep polling the message queue for locks who've already expired. Yeah, essentially locks where somebody. Let me think about that again. So yeah, all the consumers will look for message queues for locks that we need to check if the person finished or not. Then it'll pop the lock out of the message queue, and then essentially, but when someone has the lock, they have exclusive ability to go to the checkout flow for that specific ticket. And once they do, we'll update the database that they took that ticket. But then, if they didn't take that ticket, the consumer will pop out that lock and see that they didn't have that ticket and insert that lock back into the Redis cache. But if they did do it, we don't add it back to the Redis cache, so somebody can get that ticket. And that allows us to, the message queue allows us to kind of time how long people have, and that's completely server driven. And also, yeah, and then basically we'll just have to maintain the lock IDs. So if someone has an invalid lock and then tries to go through the checkout flow, we or try to buy something with that, then it won't work. Yeah, that's kind of how we'd make that work. And how would you design this to prevent users? So you don't. The problem is you don't want somebody to be in the middle of checkout flow and someone else bought it. That's why we want to put a lock on it and only have one person trying to check out for one specific ticket. And in the time being, it's gonna be blanked out for others to select. And then if somebody doesn't go through with it, it'll appear again. So basically, in the app server, we'll also be looking for tickets that no one has an exclusive lock for if we want to show the event or the ticket the seating chart that's available. Get feedback. Wow, that's a lot of talking. We propose an excellent using distributed locks with Redis, which is highly scalable. Okay, this selects my approach. Your design effectively prevents users from losing seats during checkout by implementing a two-phase booking process. You include a message queue to handle lock expiration. Cool. Consider elaborating on how it's set for the Redis lock to automatically expire after 10 minutes. You could provide more detail on the process of updating the ticket status in the database. Yeah. Okay. What's the sample answer? So they have a book it service. They have a Redis. They do the Redis lock as well. Interesting. So I have a ticket lock. Yeah, and they talk to a different. I don't know why I did the message queue. Maybe I was overthinking. Maybe you could just you can just use the distributed lock and then it expires and then other people can grab that lock. And then, yeah. To implement the two-phase booking process and prevent users from losing seats, we'll use a distributed lock with a 10-minute time to live. When a user selects seats to reserve, the client sends a post request. Okay, you attempt to book the lock. The reservation ensures that no other people can reserve or book the same seats. If the user completes the purchase with the 10-minute, if the user does not complete. Cool. No, this is great. This is a great website, and the video is probably getting way too long. So what I'll do is, next question. How can you design scale support up to 10? I already talked about that. Should I just skip all these and then see? Yeah, I already kind of talked about how can make the seat map on the event automatic refresh. How can you make the seat map on the event page automatic refresh to display the latest seat availability in real time? We can solve that using WebSockets essentially. How would you implement a virtual waiting room that queues users for popular events and grants access based on their queue position? Yeah, we can do a message queue there. So essentially, when they're trying to get they'll need to when they want to access the seat map, they'll just get put in the queue, and once they get out of the queue, they'll be able to access the seat map. Let's just skip and finish. Ooh, what happened? No way, they put me through the checkout flow. Not even gonna give me my mark? But that was a really great. Go back to practice. Wow, that was really great. I don't think it gives you a final mark, so I'll go do these deep dives separately. But it looks like I did really well on the different parts, except for the non-functional requirements. I forgot to talk about burst stability, and latency should have been more specific. But overall, that's how I would approach this problem. And depending on what the interviewer wants to do, they'll probably want to choose like one or two deep dives, and definitely it won't go over all five. But that's kind of like how I would approach the system design. So cool. That's a pretty interesting video. This is my first time trying this platform, so it's really cool to see it work. And I'll probably try it out some more and give more feedback on the different parts of it. But that was really fun. Appreciate Hello Interview for building this. And I'll see y'all in the next video.